When are you gonna go through to yesterday's assignment?
Come again.
When are you gonna go through the assignment?
I'll let you know. If possible, today only I'll go through. Okay?
Yes, thank you, ma'am.
Okay. So yesterday we were discussing bridge rectifier, that is full wave bridge rectifier. Along with that, few of the requirements which are required in order to design a bridge rectifier, that is say percentage regulation, efficiency, DC load current, RMS value of load current, DC load voltage, RMS value of load voltage. Along with the derivation, we were this is what we were discussing yesterday. So coming to today's session, we are left out with two more considerations. One is yesterday, till here I did, right? That is rectification efficiency. Any doubts till now?
No doubt.
Any doubts till now?
No, ma'am.
No, right?
No, ma'am.
Okay. Okay. So next coming to the next consideration, that is seventh consideration. Is it seventh or eighth?
Seven.
Seventh. Okay. Ripple factor denoted as gamma. Okay. So what do you mean by ripple factor? Anybody? Can anyone tell me what is ripple factor? Okay. So the thing is that the input for a rectifier is an AC input, right? So the output, whatever you are getting, it is not a pure form of DC. You are getting a pulsating DC like this. Okay. So here, in order to make this a pure form of DC, we are giving this as an input to the filter, and after filter we have voltage regulator and so on and so forth. So now what happens here is, look at this AC signal, and here you are getting, this is not a pure form of AC, pure form of DC at the output. You are getting some noise, or we can say ripples. Ripples are nothing but noise-like impurities which are present in the rectified output. Okay, so how much amount of AC component which is present in the DC output is measured by using measured by ripple factor. So this is denoted by the ratio of VAC divided ratio of VAC over VDC. So that is RMS value of AC component which is present in the rectified output of the DC component is denoted by ripple factor. I shall write the definition. It is the ratio of RMS value of AC component present in the rectified output to the DC component the rectified output. So ripple factor, it is VAC over VDC, and both are measured with respect to output. Okay. So here you have derived the relation for VAC, VDC and all. So here one more equation will come into picture. The total power will have to consider. Okay. The total output power is the sum of power with respect to DC and AC components. With respect to this, we will derive the ripple factor. The total output power better I shall write, is the sum of DC and AC components. Okay. I shall, instead of power, power is directly related to voltage, right? P is equal to I squared R or V squared by R, correct? So I shall measure the entire with respect to V. So that is the reason I'll consider the total RMS value of voltage. That will be, I'll equate it to the voltage, DC value of voltage and DC value of RMS value of voltage. So therefore, the total RMS value of the rectified output since I am considering the voltage, I'll square this one. I'll equate that to DC value and AC, sum of DC and AC. Okay. So this is VRMS the whole square, that is equal to VDC the whole square plus VAC the whole square. So divide this equation throughout by V square DC. So what you will get? VRMS by VDC the whole square. Okay, that is equal to 1 plus VAC over VDC the whole square. What is VAC by VDC with respect to this? It is gamma, that is ripple factor. Correct? Guys, are you understanding?
Yes,
Till
ma'am.
this step, is it clear?
Yes,
Till
ma'am.
this step,
Yes,
is it
ma'am.
clear? Okay. So therefore, I shall equate VAC by VDC by gamma, that is equal to gamma square. This is VRMS by VDC the whole square. Okay. So therefore, gamma is equal to square root of VRMS divided by VDC the whole square minus 1. So now, yesterday we have derived the relation for VRMS and VDC, right? Can anyone tell me what is VRMS from yesterday's derivation?
VM by root 2.
VM by
Vm
root 2
by root 2 divided by 1
plus
plus
2 RF by RL.
2 RF by RL.
2 RF by RL. What is VDC? It is 2 Vm by pi divided by 1 plus 2 times of RF by RL. So now what you have to do is substitute these two in this equation. Okay. And get me the gamma value. Quickly you solve. Abhinay? Abhinay Rajput?
Yes, ma'am.
Are you understanding?
Yes, ma'am. Yes.
Okay. 2 by pi is there, divide by root 2 is there. All those things you solve.
Pi square by 8 minus 1.
Yes,
Root
ma'am.
of pi square
Root
by
of pi square minus pi 8, ma'am.
No, that pi and all you solve. Pi value and all you substitute, and you get me the value of gamma. Is it 0.483? If you keep the value in percentage, you'll get 48.3%. Is it so?
Yes, ma'am.
Others?
1.48.
Yes, correct. Point 483?
Yes, ma'am.
Yes, ma'am.
Yes. All are getting 0.483?
Yes, ma'am.
Okay. So, what do you infer from this? Can anyone tell me? What is your inference? What does this 48.3 represents?
the percentage of AC that is still left after rectification.
Correct, correct, correct. So after rectification in the DC output, that is pulsating DC output, whatever you get, in that pulsating DC output, you have got 48.3% of AC components, and those that is called as ripple. Okay, that is the meaning behind a ripple. I mean, this factor is called ripple factor. So this is how we measure ripple factor. Amount of ripple is present in the bridge rectifier output, whereas you have got 121% when you consider half wave rectifier. So that is the reason when you compare ripple factor in bridge rectifier, the ripple factor amount is quite less. So that is the reason this is used for majority of the applications than compared to half wave rectifier and full wave rectifier with center tap. Okay. So the next parameter under consideration, next one, peak inverse voltage. In short, we call this as PIV. This is similar to, I shall write it over here. This is similar to VBR, that is reverse breakdown voltage of semiconductor diodes. With respect to rectifier, we call as peak inverse voltage. Okay, so better I shall write the definition so that when you refer this notes, it will be useful. Orally, if I tell, you'll forget. That is the reason. If I write no, at least you'll remember. That is the reason. So peak inverse voltage is the maximum reverse voltage to which the diode can be subjected to. Say if the reverse voltage, okay, I shall write. If the reverse voltage across the diode is greater than peak inverse voltage, PIV rating, the reverse breakdown of the diode occurs which causes permanent damage to the diode. So this PIV rating, it is similar to the reverse breakdown voltage, what you have come across under semiconductor diodes. Okay. So as the reverse voltage increases, if you keep increasing the reverse voltage, diode could not sustain that much amount of that much amount of value, okay, of input voltage. So after some time, what happens is gradually it will go to breakdown state. So that is called reverse breakdown, and it causes permanent damage to the diode. So PIV rating or the PIV equation, PIV value, it is equal to VM for bridge rectifier. What does VM represents? What does VM represents?
Voltage.
Can anyone tell me what does VM represents?
Peak voltage, ma'am.
Yes, it is peak voltage. It is peak voltage of the diode. Please make a note of this. Just a second. Give me one minute. Have you made a note of this? So this is basically a quick
Yes.
question you can expect. Sometimes they'll ask you what is the PIV rating of bridge rectifier. Then you'll have to say it is basically peak voltage. I mean, sometimes some value they will give. So for that you'll have to find VM. So VM will give you PIV. Next. We shall solve few tutorial questions on rectifier. Take down first question. Better I'll write the question. 110 volts, 60 hertz, AC main supply is connected to.
Ma'am, is this a question?
Yes, this is the question. Please make a note of it. Is connected to full wave bridge rectifier through a 10:1 transformer. The forward resistance, I shall write this as RF, of the diode is given by 6.8 ohms and the load resistance RL is 82 ohms, determine DC load current, DC output voltage, and rectification efficiency. This is the question given. So can you try to solve this? You have all equations with you, right? First, you list the parameters, whatever given.
Ma'am, the 10:1 is N1 by N2. Ma'am.
10:1 transformer means N1 is to N2.
Ratio of number of turns.
Correct. Okay, listen here. So VAC they have given, that is 110 volts. What does this represents? V1, right? That is primary voltage. Guys, are you there?
Yes, ma'am.
Yes, ma'am. Ma'am,
Yes,
Okay,
ma'am.
so 110 volts. Okay, are you
110 is
understanding?
it RMS or peak, ma'am? In the question.
Wait. I'll tell you. It is only V1.
Okay.
It is only V1. Okay, that is primary voltage. By using this, you have to find the peak value. Next, RL they have given 82 ohms. RF they have given 6.8 ohms. And the turns ratio they have given, that is N1 is to N2, that is 10:1. Okay. So, and they're asking you to calculate IDC and VDC and efficiency. Shall we solve? So we know this relation V2 by V1 equals N2 by N1. Correct. So I can write this as 1 by 10 into 110. This will be equal to 11 volts. This is V2, that is secondary voltage. So did you understand the difference between primary voltage and secondary voltage? This is by using step down transformer. It will down convert the value from higher to lower. Guys, did you understand?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Till this step, is it clear? So V1 represents primary and V2 represents secondary. Once you find primary and secondary voltage, next to find by using the relation V2 equals Vm by root 2, that is RMS value of V2 in order to find Vm. So find Vm, that is V2 into root 2. So how much you'll get?
$15.55.
15.5 volts. Okay, once you calculate Vm, find IDC. What is the relation for IDC? What is the relation for IDC?
2 Im by
2
pi.
IM by pi.
2 Im by pi. Yes, substitute. Substitute and tell me what you'll get. You have all relations, equations, everything you have with you.
Is it 103 milliamps?
Correct. 103.6 milliamperes.
Yes.
Next, find VDC. Yes, Khushi, are you getting?
Yes, ma'am. Just a second. I'm solving.
Eight 8.5 volts.
Correct. Either you can use this equation or you can also use this equation, that is IDC into RL. So 8.5 volts is the answer. Others, please verify. Don't simply copy. You solve and verify the answer and then you write.
Ma'am, for the CIE, will the derivations of all these equations also be there?
Derivations, they'll not ask.
So we just need to remember the formula, right?
Yes, yes. See, I would have given the equations directly, but you'll not understand anything, those parameters, if I write directly, correct? So that is the
Yes.
reason I did the entire derivation.
Okay, ma'am. Thank you, ma'am.
Okay. So VDC, did you calculate? 8.5 volts you'll get.
Yes, ma'am.
Shall we proceed? Next is efficiency. Calculate efficiency, that is 0.812 divided by 1 plus 2 times of RF by RL. Keep the value in percentage, so multiply by 100.
Ma'am, 69.
11.5.
How much?
69.8.
69.5.
69.6%. Others, please verify. I request everyone to type the answers in the chat box. I'll not come to know whether you have understood or no, or whether you are solving.
Yes, ma'am. 69.6.
Correct, no? Okay. So please type the answers in the chat box once you calculate. Okay. Next. Shall we proceed?
Yes, ma'am.
Yes, ma'am.
Is this over? Shall we proceed? Okay. Next
Yes,
question.
ma'am.
Okay, second question. Please make a note of the question. Better I'll write the question. A bridge rectifier. Using identical diodes produces a DC current of 125 milliamperes through a 1.8 kilo ohms load resistance if the AC input is 220 volts. Calculate the turns ratio of the transformer if each diode has a forward resistance of 65 ohms. Make a note of this question. Can you try this? They're asking you to calculate turns ratio. You have all relations with you, at least give a try. Okay. Okay, listen here. First, let me list out the parameters, whatever they have given. It is IDC is 125 milliamperes. They have given load resistance, that is 1.8 kilo ohms. Forward resistance 65 ohms. VAC they have given, that is V1, right? That is 220 volts. And they're asking you to calculate turns ratio, N1 is to N2. This is the question. So IDC they have given, right? So what is the equation for IDC? What is the equation for IDC?
2 Im by pi.
2 into Im by pi, right? So use this equation. Find Im. Im is Vm divided by 2 times of Rf plus RL. So before solving this, find Vm. How do you find Vm? How do you find Vm? 220 volts, that is V1 they have given, right? Divide by root 2 you do. You'll get Vm.
Root to VDC, right?
VDC. Why VDC? Okay. Just a second. Okay, what you can do is use this relation. Okay, IDC you know. Can you find Im?
Yes, ma'am.
How much you'll get?
196.
196.25 milliampere.
Correct. Okay, right. It is 196.3 milliamperes. Okay. So now you substitute and get me Vm value. Substitute in this equation. Get me Vm value. How much you'll get?
378.76, ma'am.
Correct. It is 378.8 volts. Correct.
Yes, ma'am.
So, you know secondary voltage V2 is equal to Vm by root 2. This is basically RMS. Use this relation, find V2. Find secondary voltage V2.
$267.8.
How much? 267.8.
267.8. Yes, ma'am.
267.8 volts.
Yes,
Now
ma'am.
please check again. V2 value 267.8 you got.
Yes, ma'am.
Yes, ma'am.
Others?
Yes, ma'am.
Yes, ma'am.
267.9.
Okay, fine. So, you know V1 by V2 equals N1 by N2. Correct?
Yes,
So,
ma'am.
V1 value you have, V2 value you have. V1 value they have given primary voltage, secondary voltage just now you calculated. So, substitute and get me the ratio, how much you'll get?
And here how we got Vm?
Come again?
How we got Vm, ma'am, here?
How you got Vm? See, by using this relation, Im equals Vm divided by 2 Rf plus RL.
Yes, ma'am, but Vm,
Huh?
how Vm is 378.8 volts.
Did you calculate Im?
Ma'am, do we have to represent N1 by N2 in fractional form or is decimal fine?
Fractional form? No, decimal is fine. Can anyone tell me how
Turns
much?
ratio.
Then it is,
0.82.
yes, ma'am,
Is it
0.821.
0.
No, is
Yes,
it
ma'am.
one? Is it
0.821.
just a second? Is it 1 is to
1.22.
1.21?
1.22.
1 is to
Yes.
1.21?
Yes, ma'am.
Okay,
Yes, ma'am.
guys, one more thing. Okay, what we have to do is we have to find the RMS value for both. Okay, V2 you calculated, that is 267.8 you got. Can you tell me the RMS value of V1? Is it 311.12?
No, ma'am.
No, ma'am, it's 155.5.
Wait, just a second.
155.56.
This is the answer. Just a second. 1.2176. This is the answer. You verify once.
Yes, ma'am.
Wait, just a
Yes,
second.
ma'am.
Let me
Correct.
open the calculator because even I don't have calculation with me. Only answer I have.
Yes, ma'am.
Let me also
This is
verify.
coming properly. It's ma'am.
Wait, V1 value is 220 divided by. Is this the answer you are getting?
Yes, ma'am. For N1 is to N2.
Yes, ma'am.
Yes.
N1 is to N2. Right. This is the solution. Others, please
In the
check.
question, if they ask turns ratio, do we do N2 by N1 or N1 by N2?
See, V1 by V2 equals N1 by N2. If you take V2 by V1, then it will become N2 by N1.
Yeah, I did N2 by N1, which is 1.22 is to 1. So will I get marks for that?
Hey, that's okay. It depends on however, no, how you represent. V2 by V1 equals N2 by N1 or V1 by V2 equals N1 by N2. Both are one and the same.
Okay. Yes.
Okay.
Thank you.
Any other questions? Please make a note of the answer.
Can we leave it as a decimal, like calculate this fraction and then write it as 0.821?
No, you have to write in terms of ratio because they're asking you ratio, right? N1 is to N2. In that form only you write.
Okay.
Okay. So even you can calculate V1 by V2 and you can keep that value also, but provided they're asking you turns ratio, you keep the value in terms of ratio. Okay. Shall we proceed?
Yes, ma'am.
Okay. Next question. Make a note of this question. In a full wave bridge rectifier, the transformer secondary voltage is 100 sine omega t, RF 25 ohms, RL 950 ohms. Find VDC, ripple factor, efficiency, peak inverse voltage, percentage regulation, DC load current, RMS load current. Okay. Calculate all the parameters. So here, secondary voltage they have given, that is V2 equals 100 sine omega t. What do you mean by this? How do you write V2? How do you represent V2?
Vm into sin omega.
Vm sine omega t.
Vm sin omega t.
Correct. So Vm value is 100. Did you understand? So
Yes.
directly you can consider Vm to be equal to 100 and then proceed.
Could
Okay.
you show the
So I'll
question?
give this. I'll leave this as an assignment. You tomorrow before coming to the class, you solve and come. Okay. So make a note of the question. Is it over?
Yes, ma'am.
Yes, ma'am.
Okay. So now shall we discuss the tutorial answers? Guys, are you there? Shall we discuss tutorial answers?
Yes, ma'am.
Yes, ma'am.
Okay. So
Yes,
please
ma'am.
open whatever you have solved. Please open. We shall verify the answers. So for the first question, how much did you get? Yes, all of you please post it in the chat box. First question answer. First question, what is the answer? Yes, Bhuvan, Shreyansh, Walid Siraj, Vidhu Agarwal, Vijaya, Mihira. Okay, all answers are correct. It is approximately 1.5 milliamperes. Second question. Okay, fine. Coming to second question, what is the answer? ID. They're asking you to calculate forward voltage. May I know the answer? So I lost the connection. Point 682 volts. Yes. 0.682 volts or 682.3 millivolts. Please verify the answers. Next question. Third question. What is the answer for the third question? They're asking you to calculate reverse saturation current. One of you please read out the answer.
12.83 nanoampere.
Milliampere.
12,
12.74 nano.
12.8 nanoamperes.
Yes, ma'am.
Correct, correct. Okay, correct. Please verify. Fourth question, what is the answer?
And 12.81 ohm.
ID value, you tell me how much you'll get?
2.03.
2.5 milliamp.
2.02 milliamperes.
Yes, ma'am.
Correct. RD value?
12.85.
12 ohm, ma'am.
12.87. Correct. Please verify. Next question. Yes, what is the answer for the fifth question? Fifth question, what is the answer? $62.
Ma'am, there are two parts, ma'am. For A part, it's 62.32.
62.32. I was 61.
Shall I show you one shortcut method to solve this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Fifth question. Listen here. They're asking you to calculate the change in the voltage drop. Okay, with respect to 20, 20 milliamperes as well as 150 microamperes. So what you can do is that, the diode current with respect to current one, that is with respect to 20 milliamperes, I'll take it as I1. With respect to 150 microamperes, I'll take it as I2. Okay, that is equal to Is into. You need not calculate two parts. You need not calculate Is separately and then solve the change in the voltage. In one shot only you can solve. Just have a look at this. E raised to the power V1 divided by eta Vt. I'll take this as 1. Next, I2 equals Is into e raised to the power V2 by eta Vt. I'll consider eta value to be equal to 1 because they haven't specified in the question. Okay. So I1 by I2 you do. What you'll get? Is and Is will get cancelled. You'll get V1 by eta Vt divided by e to the power V2 by eta Vt. Correct? Is and Is will get cancelled. So I1 by I2, you can write this as e to the power V1 minus V2 divided by eta Vt. Okay. So if you apply natural log on both sides, V1 minus V2 divided by eta Vt, natural log of I1 by I2. Ln represents natural log. You have ln in your calculator. Please apply natural log. So substitute and tell me what you'll get. V1 minus V2. Eta value is 1. This is Vt multiplied by ln into This is 20 milliamperes and this is 150 microamperes. So solve and tell me how much you'll get. This is what they are asking, change in voltage. How much you'll get? One of you please read out the answer. Guys, are you there?
7.48 into 10 raised to power minus 15.
No. What is VT value? 26 millivolts. Correct. It is 127.21 millivolts is the answer.
Yes, ma'am.
Please verify. This is the answer. I hope you have made a note of this. If not, I shall share the notes. You need not worry. Tutorial 5th question answer.
Ma'am, when will you be sharing the notes?
I'll do one thing. Whatever I have done till today, I shall share in another sometime.
Okay, ma'am. Thank you.
Okay. Yes. Okay. Next. 6th question. What is the answer?
$18.1 million.
Tell me ID. Tell me RD. Tell me IAC.
Ma'am,
Tell me
ID is
VAC.
0.303.
0.303 milliampere.
Yeah. RD is 85.8.
RD is
85.8.
85.8. Correct.
IAC is
Next.
5.4.
5.4.
5.5 micro.
Micro is it?
Yes,
Yes.
ma'am.
Okay. Next VAC.
18.1.
18.09. 18.1 millivolts.
18.08. Yeah.
Correct. Okay. Okay. Fine.
Ma'am, how much difference between the values will be taken? Like, I've got 18.08 millivolt.